Hello, 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 geometers. Today we are going to look at mid-segments. Ooh, there's a good new word for you, of triangles. Our goal is to use properties of mid-segments to solve problems. So by way of review, we're going to look at a few formulas. The midpoint formula is the average of the x's and the average of the y's. The distance formula, which is essentially Pythagorean theorem with a square root. So it's the sum of two squares, and then we take the square root, and the slope formula, which is your change in y over your change in x. So by way of also review, we remember that the slopes of parallel lines are the same. So let's take all that information, and we are going to use the diagram and the information above and to follow the steps, and we're going to show all the work in the space provided. So let's find out where the midpoint of JL is. So up here, JL, so here's our friend J, and here's our friend L. So the midpoint is going to be, remember that we have to add the x's together, divide by 2, and add the y's together, divide by 2, the average of each coordinate piece. So down here, we say -2 plus 6, all divided by 2. And remember, it's a point, so I'm going to put it in point form. And then the other one will be 3 plus a -1. And when we simplify, we get 2, 1. So if I were to look up here and find 2, 1, it would be right here. And clearly we can see that we have the midpoint right there. So I'm going to go ahead and mark that, saying that this is congruent to over here. So I also am going to mark that point M. Now please repeat that process, but this time you're going to do KL. And just to show you, KL will end up being over here and point N. We do need to do the arithmetic there as well. Okay, next, step 3 says that we're going to draw MN. And this right here is called a mid-segment. What makes it a mid-segment is because it connects two midpoints. Okay, now we begin our conjecturing. We start to think about how this side here relates to anything else around here. Well, clearly, if I look here and I look here, they look pretty darn parallel. Another thing to consider is how long this is relative to this. And if I had to take a guess, I would say about half. So my conjectures are that this has some special properties, that this is going to be parallel, and the length of this is about half. So let's calculate JK using the distance formula. JK equals the square root of 4 plus 2 squared plus 5 minus 3 squared. And now let's go ahead and simplify. And here I get 36 plus 4, keep the square root, and the square root of 40, and that can reduce to 2 radical 10. And now when you do that whole process again for MN, we end up getting radical 10. So our first conjecture is correct. What can we conclude about the distances? Well, it seems that JK is going to be twice as long as MN, or another way to say that is that MN is half as long as JK. Both are saying the same thing. Now let's go up here and count the slopes. So to get from J to K, we go up 1, 2, and go right 1, 2, 3, 4, 5, and 6. So that means the slope. And so we get 1/3 here. And now let's count over here, going up 1, right 1, 2, and 3. And what do you know? The slopes are also 1/3. So down here, what are the two slopes? 1/3, 1/3. Conclude what about those two? Well, those two, JK and MN, are parallel. So which brings us to this theorem. If a segment joins the midpoint of two sides, and we call that a midsegment of a triangle, then the midsegment is parallel to the third side and is 1/2 as long. So by way of a diagram, we'll look here. So midpoint to midpoint such that this is congruent here and this is congruent here. So what do we know? If I call this AB and call this DE, then two things we know. We know that AB is parallel to DE, and we also know that AB is 1/2 the size of DE. So the first line of business here is that we're going to identify 3 pairs of parallel segments in each diagram. So the first thing we notice is we've got lots of congruences. So since this here is congruent to here, we have a midpoint, and AM is congruent to AO, we have a midpoint and another midpoint here, which means we have lots of midsegments. BC is a midsegment, AC is a midsegment, as is AB. So in terms of parallel, AC is going to be parallel to the third side over here, which is MN. Continuing on, BC is going to be parallel. BC is parallel to MO. And lastly, AB is going to be parallel to ON. And so just to get a little more practice here, let's find out where AB is. And AB is here. And since ZY is a midsegment, why? Because that's congruence there, and the triple here is congruent. So ZY is a midsegment, so ZY is the segment that is parallel to AB. So let's look down here. Now let's deal with some numbers, not just parallelage. If QR is 30, right here, and we are also told that each of these are the midpoints, we know many things already. So we have 15s right here, and we also know that this has to be 15. And since RS is 30, this has to be 15, 15, and this is 15. And finally, SQ is 18, so that has to be 9, 9, and 9. So the value of MN is clearly 9. And now let's look at 2 examples that are not as straightforward, but since we have congruence here, we have a midpoint there, congruence here, so we have a midpoint here, hence midsegment. So since this is a midsegment, we know that this is half as long as 54. So there are 2 ways to write that. We can either say 3x is half the size of 54, or we can flip it around and say that 54 is twice as long as 3x. It doesn't matter which one you prefer. So let's stick with this one down here, 6x, and then finally x is going to give me 9. And the same process over here is I know that this one is half as long as this, or I can go the other way and say 10x minus 21 is twice the size of 2x. So 10x minus 21 equals 4x, and then 6x equals 21, and x is going to give you 7/3 in the end. All right, practice these other ones here, and the last thing we want to do is look at one application. And if you are given a lake and you want to try to find a distance across it, if you were to create a triangle that goes across, across, and you just find midpoints of things, then we can now find out how BC relates to anything else. So since BC is parallel to the XY, we know that BC is going to be 2.5 miles across. And we know that AB is parallel to this one here, and also half of that. So we know that AB is going to be 3 miles. So when we add those two together, we get 5.5 miles. and that is the kayaking portion. And the other part is walking from A to X to C. So AXC, AXC, so this distance here, and that is going to be 2.5 there and 3 there. So it turns out they are exactly the same distance whether you walk this region here or kayak this region here.